Hello, good afternoon, and welcome to today's session. Once again, my name is Ridwan Sadahuddin. I am excited to take you today, as always. So today we will be discussing importance of Numpy, then we'll take more hands-on use of Numpy. So we'll do a slight recap of what we did yesterday before we proceed with what we have to do today. Okay, so I'll wait to people's chat before I move on, to be sure that everybody can hear me and can see my screen clearly. So I'm going to pause a bit and wait for people to chat and let me know they can see and hear me clearly. So please, if you're online, send a message to indicate that you can see and you can hear me. Just a moment, please. Okay, so I'm waiting for people to chat up and they can see my screen. Okay, thank you. So welcome everybody once again. So today we'll be discussing importance of Numpy, more hands-on use of Numpy, and we shall take at least one quiz, and at the end we'll have one assignment. So let's do a little bit of recap of what we did yesterday. So yesterday okay, so we're supposed to start with a quiz. I almost forgot that. So I'm going to paste the link to the quiz for everybody to just a moment. I'm having bad connection here. Yeah. Okay, so somebody said the screen is blurry. I'm hoping it's not the network that's causing that. So I just posted a link to the chat for us to attempt the quiz. So you can attempt it immediately, but it's not mandatory that you do it immediately. You can take your time and submit it later. So, but if you can, okay, so I would like to know if the screen is better now before I move on. So I'm waiting for your feedback. So the network is still bad. So people can't see my screen clearly. Okay, so as soon as it gets better, please let me know. Good, it's better now. Thank you. Okay, so to recap what we did yesterday. So yesterday we learned how to create a Numpy array by passing an object, a list for instance. So we get an array here. So let's pass it to a variable. So we'll print the variable. You can as well print the type by calling dtype on it. Yeah, so this is int32 type. Also I think we learned to create array from range, from a range. So array range, how to use array range. So say we want array from 2 to 15 with 2 steps or 3 steps. Let's say 3 steps. So this is going to create it. So we have 2 plus 3 5 plus 3 8 plus 3 11. So this is another way we can create array. Also, we looked at how to create arrays from things like zeros or an array of all zeros. So I'll pass in the shape I want, assuming I want just a one-dimensional array. I can just say np, excuse me. So I can just zeros. Yeah, so a one-dimensional array of zeros, and that's it. So if I want a two-dimensional 4 by 5, so I pass 4 by 5. If I want a three-dimensional 4 by 5 by 3, I pass it, and there we have it. 4 by 5 by 3, and so on. So we learned about some attributes like d type. So let's say r does d type, which will return the data type in the array. We also learned how to create arrays, that by specifying the data type. So say we want this to be float, even though it is integer that I've passed in. So if I pass the array argument as float, so it's simply going to create float type array. So we can print the data type of the array, and we can see it's float 64. So moving on to today's session today is going to center around what makes Numpy such a go-to language for most data scientists. As a data scientist, why is it so important for you to learn how to use Numpy? So there are 5 reasons here I got from a source, a website, dice.com, and they list these 5 reasons which I consider apt. So the first of these is it's fast, and that is really a big advantage for Numpy. It's well known that Python is relatively slow, is a relatively slow language compared to most other lower level programming languages, especially compiled languages, because Python is interpreted. However, this Numpy package allows Python to achieve identity or similar speed to one programming languages, especially when dealing with mathematical operations. So on that, Numpy is very fast. Then it works very well with SciPy and other libraries. So since our purpose of learning Numpy is to be able to use it in data science, and as a data scientist, you will definitely find yourself using packages for scientific computing, such as SciPy. So SciPy is a scientific Python package that is well suited for building model training and testing and so many other things. So it works very well with this library, and so many other libraries also leverage on the speed of Numpy and the way it represents data. It also lets you do matrix operation or matrix arithmetic. So yeah, because in mathematics you often find yourself dealing, or let me say in data science rather, you'd often find yourself dealing with multi-dimensional data, and it's quite easy to represent it in form of matrix, and Numpy excels so well at doing this. Irrespective of the dimension, it's able to handle it. It has lots of built-in functions, and this is especially going to come handy. I can bet that Numpy has so many built-in functions that it can feel like you're learning an entirely new programming language if you have to learn how to use Numpy in total. So it can feel like you are learning an entirely new programming language. So it is that wide and broad. So it has a lot of built-in functions that do amazing things. So it also has universal functions. So universal functions that you would call once, and it applies to everything in a grid, in an array grid. So that's a universal function. Take for instance, you want to square every number in a matrix, let's say 100 by 50 by 10 dimension. That's a relatively big array. So if you were to iterate through this array with Python, for instance, and square the numbers, so you would find yourself running that operation at a very costly, or let me say it's the operation taking quite a while. However, Numpy allows you to a universal function that simply does that on all the items without needing to loop. So it does it highly efficiently at a blazing speed. So we'll see some of this towards the end of today's class. So more on array creation. So let's get hands-on now. More on array creation. So since yesterday we've discussed, or we've shown how we can create arrays from an array range. So array range allows you to create array by saying, okay, this is the start, this is the end, and giving numbers by stepping by this amount, just as we showed above. So similarly, this linspace method allows you to specify the start and the end. But unlike in the case of a range, where you can only step by whole numbers, in linspace you can step by decimal numbers, and you're not actually stepping your items you want to return between a range, and the items have to be evenly spaced. So I say evenly spaced, and I'm emphasizing on that. The items have to be evenly spaced. Just a moment, I want to clear my cell output. Yeah. So in this example, okay, so this is how the method is used. So you call numpy.linspace, you pass the start argument, you pass the stop argument. So the start argument is 1 here and the stop is 5, and you tell how many items you want, how many equally spaced items you want returned between the range, the start and stop range. So between 1 items returned. So there are other arguments you can pass in, but we're not really. You can pass in the data type, you can pass in the red step. Not quite sure what that means. I'll have to probably look it up. So, but we're not interested in that, so we'll just go on. So here I say from between 1 and 5, give me 20 evenly spaced numbers. So here it starts 1, 1.21, 1.42, 1.63, and on till 5.0. So this could be changed to any number and it still works fine. So say 50, and say 49, let's say 99, and there you go. So let's move on. So another method that allows us to create an array, and if you look at the array creation we're dealing with now, we're not really specifying the object. We're simply telling Numpy that give me an array that meets or that looks like this. So in this example, we're saying we can create an array that doesn't have any pattern to it, that just generates numbers in a highly randomized way. So here it's the empty method simply creates randomly initialized array. So it can be integer, it can be float, depending on what you specify. So here I'm saying give me 4x6 array of data type int, and give me anyhow. I don't really care, just give me random numbers, although we're still going to see random methods ahead. So let's see what it gives us here. So here, because I passed in ints, every number here is an integer, and it simply generates arbitrary numbers. So we can see very large numbers, some not so large, some negative and others positive. If I run these again, the set of numbers are going to change. Okay, so if I numbers, so these numbers it's just like it's empty because there's no pattern to it, there's nothing, it just gives you arbitrary numbers. So if I want to change the shape here, say I want 4x10, so there I have it again. So 4x6 again. So moving on, Okay, so this is another example of float. Yeah. So I can change this back to int. Yeah, so yesterday I mentioned how you can get help with functions and methods by simply calling help function on them. So assuming I want to know what mp.0 does, so I call it on it, and I'm able to read through and even see examples of how it is used. So moving on. Okay, so the screen is blurry. Let me know when it gets better. I'll pause a little bit. So I'm waiting for you. You can tell me when the screen gets better, so I can fire on. Excuse me. Okay, so it appears it's a little better now. Yeah, thank you. So here we create functions and we create arrays of zeros and array of ones. So array of zeros of 3 by 5 dimension and array of ones 3 by 5 dimensions. So let's run it and see. So we can see array of zeros, all zeros, and array of ones, all ones. So now, let's see how to generate random numbers as arrays as well. So we'll start with just generating random integers. So random integers. So here I just want a single random integer. The syntax. So let's see how the method is defined. What parameters it takes. Rand int. Yeah. So there you go. So it takes the low value, that's the lower range or the lower boundary, and the higher boundary if you want to specify, but you must specify the lower boundary. So, and it also takes the size you want. If you don't specify the size, it simply gives you arbitrary sized single integer. Sorry about that. So it appears the screen is blurry again. The screen is blurry again, so okay, so it's a little better now. So it takes low, it takes high, and the size. We can just pass the low and not passing high, size, and other parameters. So let's go to the example. So here we see a random integer between 0 and 10. So because we didn't specify the size, it's just going to return just one integer item. So let's run it. Oh, supposed to run this, yeah. So that's it. It gives us 6. If I run it repeatedly, it gives random number between 0 and 10. So highly random. Yeah, so that's it. So we can as well generate, so this is 0-dimensional object. So it's, yeah, 0-dimensional object. There's no dimension to it. So but we can specify the dimension we want. So say we want a 5 by 6 dimension array. So here we run it and we get a 5 by 6 dimension array with numbers between between 10 and 17. So if you look through, you'll see all the numbers are between 10 and 17. Okay, so moving on. So in this example, we're as well generating random numbers, just that we're not generating random integers. We just say, okay, give us random numbers between of shape 4 by 3. Of shape 4 by 3. So we're not specifying the range. We can as well see what parameters it takes by calling help as usual. I think we know how to do it. No need to do that again. So, but the first argument is the first dimension. The second argument is the second dimension. If you want more dimensions to it, you can as well pass others. So let's run this and see what it gives first. So this gives us a 4 by 3 array. So if you pass one more dimension to it, so let's say by 2, so we get something like this, and on and on. So next, array indexing and slicing. Array indexing and slicing. So if you have taken our introduction to Python programming class, you should be quite comfortable with these aspects. Indexing in Numpy shares some similarities with list indexing or attributable indexing in Python. The only difference is, while in Python you can have multi-dimensional data, you can have a grid-like data, Numpy allows a grid-like data, and you can as well take advantage of some advanced array indexing and slicing techniques that we're going to see later on. So in this example, I create an array of numbers from 0 to 10, and I print out from the start to the 5th item in the array. So let's go. So that's it. 0, 1, 2, 3, 4, and it ignores the other 5 items in it. So I can as well change it. I can reduce it, and it works as expected. So next, example 2 on the array indexing and slicing. So in this example, so we will create an array of numbers from 0 to 20. I will try to give it a shape. So we are reshaping it by calling a reshape method on the array. So we say reshape it to a 10 by 2 dimension. So we'll print out the original array, and we'll slice the array and print out the sliced array. So what kind of slicing operation are we doing here? So let's print out so we can explain it. So first we print the original array, and this is a 10 by 2 array. Then we slice the array. So let's see now. We say give us array starts from the first index item to the last, but move 2 steps each time. So pick from the, when I say first here, is the one indexed item, not necessarily the first. So this makes it the second item. So the second item to the last, just taking the evenly stepped. This is the second item, 2, 3. Then it ignores the third and goes to the fourth, 6, 7. Ignores the 5th and goes on to the 6th, 10, 11, and so on till 18, 19. So that is just sliced the array. So if, for instance, this step size, we make it 1, so it's going to give us almost everything except the first item. So you can see we have almost everything here except the first item. So it starts from the second and just moves 1 step without skipping any item. Okay, so in the next example, here we create a random size 4 of shape 4, a one-dimensional array of length 4, and we try to access one of the items in that array. Which item are we accessing? The second item in the array. So let's run it. So this is the original array that we created, and this is the second item in it. So we can see it's in agreement with the second item here, 0.18588.341 and so on and so forth, truncated. So in the next example, so we still create an arbitrary array by just creating an array of random integers between 0 and 20 of size 3 by 5. We'll print it out. So here we now try to access the third item in the second item of the array. So this is going to be a little tricky. So I'll print it out first before I proceed to explain what it does. So here we have a 3 by 5 array. First, the second, the third, 3, then 5 columns, or each item having 5 items in it, each item in the original array. So now what I mean by original array is the main array with the square bracket outside, with the outermost square bracket. So the main array has 3 items. So this is the first item, so this is the second item, and this is the third item. So we say accessing the third item in the second item of the main array. So I'll put main array to make it clearer. So the main array, this is the second item in the main array. So we want the third item in it. So 1, 2, 3, 4. I beg your pardon. The third item has index 2, right? So this is the third item with index 2. So in the third item, we want the item with index 3. So we want the item with index 3. So let's see, 0, 1, 2, 3, and that's 16. So that is what it prints out. So, but I show 2 ways of doing this thing here. The first way is this, and the second is this. What makes them different? Okay, so the first example here, or the first print statement here, it is able to infer the shape of it works with the shape of the array. So we know that this is a 3 by 5 dimension array, right? So 3 by 5 dimension array, and I'm saying, okay, I want the second, not the, okay, I know it's 3 by 5, right? So give me 0, 1, 2. So give me the third item out of the 3. So let me put 3 by 5. So we know this is how 3 by 5 is. So this is 1, 2, and 3. So I say give me 3. So that is the 2 here. The 3 here happens to be the second index, if you understand indexing in Python. So give me this, and 3 here means in this one that you have chosen, count 1, 2, 3, 4, and give me this. And that is what it does here. In the second example, what it does first is this 2 does the same thing as this. It first picks this, and as it is, if we choose to print it without these 3, you'll see that it's going to print the last item here, and that is 17, 0, 12, 6, 5. So, and we now say also give us the third item in this, and that is what the fourth item, the 3 indexed item. So, and that is what it does here. So now let's take advanced indexing. So in advanced indexing, we'll see some more advanced operations, indexing operations that can be done on Numpy. So in this example here, we'll first create a 3 by 5 dimensional array, and the instruction is to get the second items of each item in the main array. So this is the main array as usual, the outermost square bracket. So give us the second items of each item in the main array. So there are 3 items in the main array. This item 1 in the main array, this item 2 in the main array, and this is item 3 in the main array. So we say the second items of each. So each of them give us 0, 1. So this is the second item, index 1. This is the second item, index 1, and this is the second item, index 1. So how do we achieve that? So we can see we have 2 square brackets. So we're making use of double square brackets in this indexing, unlike the previous examples where we've been indexing by single square brackets. So in this example, so the first square bracket you can think of it as saying, okay, just the way it is here. That's what this first square bracket does. It just brings everything together. So the second square bracket now speaks to each of the item in the main array. So this main array, this is one item in it. So it corresponds to index 0. This is another item, index 1, and this is the third item, which is index 2. And now from each of these, so we now say this part of the slicer is going to give us the first item here, the second item here, the first item here as well, and the first item here as well. So let's run it and see what we get. So we get 5, 16, and 9. I'll print the original array for clarity. So we get 5, 16, and 9. So, and those are the second items of each of the items. So this is each of the item in the main array. This item 1 in the main array, item 2 in the main array, and item 3 in the main array. So give us the second of all. Okay, so moving on. In this example, we also create an array first. So what we do is we get the first two items in the array. So this is comparatively simpler than the preceding example. So first two items in the array. So of course we're talking about the main array here. So and there you go. This is the first and this is the second. So the first and this is the second, the first and the second. Okay, so in the next example, the instruction is to get the first and second. Okay, sorry, get the first. Okay, there's a slight error here, so I'll correct it. It's supposed to be get the second and third items of each item in the main array. So in the main array that has 3 items, get the second is this, and the third. Second is this, and the third. Second is this, and the third. So get the second and the third. So what we do here is similar to what we did here. So here, because we want to access each of the items in the main array, remember I said this part speaks to the main array and this part speaks to this the items in the array, or the arrays in the array. So similarly, the first part here speaks to the main array and simply returns all the items in the main array. So think of it as simply giving you back everything here. Just that in this situation, we can now index each of the items in the main list, in the main array. So this part now says give us index 2 and index 3 items of all the items you have picked here. So it simply does that, and let's run it. There you go, we get 2, 14 here, index 2 and index 3, 11, 9 here, and 15, 8 here. Okay, so next, this is an exercise, and I'm going to leave it to everybody to do. Okay, I should also mention that the notebooks of the classes will be in the description section of the video. So if you look at the description section of this video, you'll see a link to this notebook that I'm using. So you can download it. You should download it and practice yourself. It's easier to download and use it rather than having to type out everything I'm doing on your own. So just download it and make use of it. So I should also show you how to download, because we're downloading it from GitHub. So let me quickly do a demo of how to download notebooks on GitHub. It's very important. Although I've shared a link in the description of how to do that. So let me grab the, hold on, just a minute or less to grab the description. To grab the link to the GitHub repository. Okay, yeah, so this is the link. So you simply click on the link in the description and it brings you here. So it's still loading. You're going to see that it's the same thing we've been presenting so far. So you can see it. So it's the same thing. So but you simply download it. So in order to download it, you come to raw here. You click on it. So you're going to load a raw page. So here you simply save it by Ctrl S, or you right click on the page and you select save as. You can see it's telling you to simply use Ctrl S. So if you select save as, so you'll choose the directory where you want to save the file to, and you can see it has automatically picked it as IPYNB file and it saves it for you. And when you want to load it, you simply load your Jupyter notebook and you will navigate to the folder where you have saved the file and you can open it from there. If you're using Google Collaboratory, you simply need to upload it to Google Collaboratory and you will be able to access it from there. Okay, so that's it. So in this example, okay, so this is just an exercise. So this is, and I reshape it to a 3x5 array. So I'll print the original array, then I modify it here by looping through the array using mp.nditer. So this argument allows you to method rather allows you to iterate through an array irrespective of the dimension of the array. It's going to take one item at a time in the order with which it is represented in memory. So let's run this. So we can see it's created the array, and looping through the array we have this 0, 6, 12, 18. You can see just simply moving from one line to the next till the end. So if you don't want to do it this way, the other option you would have is to first flatten the array. So for instance, the array is A. So if I say array.flat, array.flat, yes, so array.flat also works. So it's what it returns is also an iterator just like this. So I can as well loop through for I in array.flat, print I and end. Oh, it didn't quite work as I expected. I beg your pardon then. Hold on, I think this should work. Okay, it doesn't quite work, so it's best to stick with nd.iter in order to iterate through array if you want each item irrespective of the shape of the array. So modifying an array. So if you have created an array, or you get an array from another object, and you want to modify the items in the array, here it is possible to do that. So here we create an array of zeros, a 4x3 array of zeros, and here we change the item corresponding to row 2, column 1. So we simply use indexing to access it. So you know, array, this statement here is going to return the index 2 sub index 1 item. So we're now saying, okay, when instead of returning it to us, no, assign the value 15 to that. So let's print it and see. So this is the original array. So this first 0, 1, 2. So this is index 2. In index 2, index 1 in that item. So index 1 in that item is this. So at this point, we're saying assign the value 15 to this point, and that is what happens here. So next example, creating an identity matrix. So identity matrix is a matrix of that has so that has a diagonal of ones. So it has diagonal of ones. It's formed, the ones in it form a diagonal. So let me create an array 3x3. Let's see it here so we can see what it looks like. So this diagonal has all ones in it. So that is an identity matrix. So it is created using the method EYEI, mp.I, and you specify the shape you want. So you could change it to 5x5. You could change it to 5x5 and it still works. So what we're doing is we're modifying it by multiplying it by 5 and see what it produces. Because 0 multiplied by 5 remains 0. Only the items with 1, that's the primary diagonal, that gets multiplied by 5, and we get this. So universal functions, we mentioned universal functions at the start of this class, and I said universal functions are functions that when you call them on an array, they get applied to all the items in the array, irrespective of the shape of the array. So in this example, we create an array and we get the square root of the array. So let's see. So square root of 4 here is 2. Square root of 5 is 2.236, blah blah blah. Square root of 2 is 1.414, and so on and so forth. So the second example, we'll see the floor function. So the floor function as well applies to all the items in the array. So simply from what we got from the previous example, from the square root part, we're simply going to round the square root, the result, down. So we'll round it down to the nearest whole number. Okay, so let's run it. So we can see 2 points still remains 2 points here. 2.236 is changed to 2 points, or just 2. 1.41 is changed to 1. 3.74 is changed to 3. So we notice that it's rounding it down. It's not just it's not doing the normal roundup. It's a floor operation, and the floor operation simply eliminates or truncates the